So what we've done to convert a variable or value of a variable that is normally distributed into its standard normal equivalent is take x minus the mean and divide by the standard deviation, and I end up with a z-score. Okay, this is known as standardizing, and also I will refer to these as type 1 problems. Now the question is, could I go the other way? Could I begin with information on how many standard deviations a value is from its mean and that it's normally distributed, and be able to come up with an actual number in units? For instance, if I knew a woman had a height, I was told that she was 2 standard deviations above the average mean for women, then I know she was here, but how many inches is she then? How tall is she? I could calculate this by using the information about women's heights, that their mean height is 64 inches with a standard deviation of 2, and reversing these operations, going backwards. So rather than dividing by the standard deviation, I would multiply the standard deviation, and rather than subtracting the mean, I would add the mean to what? To z, because I start with z. So beginning with z, I would take z, I would multiply the standard deviation, and I would add the mean to get back to, or to get to, x, however that was defined. This I refer to as unstandardizing, and I may also refer to it as an X type 2 problem. And the operations, as you can see, are just the backward operations. I'm going to multiply the standard deviation, not divide it, and then I'm going to add the mean. So for the example that I mentioned, to end up with the woman's height, if she was 2 standard deviations above the mean for women, then we would say her height equals z standard deviations from the mean. Notice I use lowercase now when I'm actually calculating a value, a particular value. So let's plug it in. Notice also the sentence I'm using to interpret this, z standard deviations from the mean. It translates perfectly into this equation. So it would be z was 2, I said. The standard deviation happens to be 2, plus the mean of 64 gives us 68, which is what we expected as 2 standard deviations from the mean.